we're here for our organization, Innovative Education. Here you have two pictures that show the disparity you have when you do and do not have enough engineers. On one hand, you have an apartment building that collapsed during a relatively minor earthquake, and you have Taipei 101, one of the largest buildings in the world that's designed to withstand nearly any sort of natural disaster. Unfortunately, the U.S. is currently experiencing a national shortage of STEM majors, that's science, technology, engineering, and mathematics. By 2020, there'll be several 100,000 unfilled STEM positions.
There are currently 50 million K-12 students in the country. If we were to get 1/10 of 1% of those students, that would fulfill all those needs. The current issue is that the current programs that exist today, they don't address the fact that there's a defining moment in an engineer's life, or a scientist, or anyone who's used technology. They're doing something and they just get that spark. Our goal is to inject that spark into their lives, to provide something, a product that will inspire them to pursue that.
So I had the wonderful opportunity to teach a Lego robotics class for 3 years at a summer camp for 4th through 8th graders. And one thing that I noticed that by using Legos, especially the Lego robotics kits, is that it really provided a good environment to give those kids that spark that Anthony just mentioned. So one thing that would happen is that every year the kids would come in and they wouldn't really understand how to build a robot out of Legos. They didn't understand the basic engineering principles or really what pieces to put together. But by the end of the program, they were coming up with more innovative designs and more robust designs than I could ever think of. And every year I saw completely new robots turned out by these kids, which always surprised me and really inspired me as a teacher. So one thing that I've noticed with the kids is over time, as they would put more and more innovations on their robot, and as they would push their own engineering limits and the engineering limits of Lego pieces, they became really attached to their robot. Their robot was kind of like their champion in battle. They had a connection to it because it was theirs. They had built it. But one thing I'd always noticed as well is at the end of the course, and as every teacher who's ever dealt with Legos or any parent with kids, is that Legos are everywhere, the kits aren't sorted, and it is the teacher's job to pick up all the pieces and resort them, which is a very long and tedious process. What we propose to do is to make a modular system that the students and the teachers would collaborate on, and this modular system would help sort the Legos back into their kits and really free up a lot of the teachers' time. This is good for the students because it brings them back to be attached to that machine. That machine is theirs. It's not the teachers, it's not anyone else, it's the whole group, it's the students. And it also helps the teacher by not having to give them that extra hour after school, or a few hours depending on how complex the kits are, that it would take to put all those kits back together. And by doing this, we would hope that it would inspire more teachers to use the principles of Legos and Lego robotics kits and bring them into the classroom and help give students that spark.
One of the important aspects of our company and this project is that it's open source, meaning that it gives you two primary benefits of access to engineering, high-level technical data, so that the students in a certain grade don't have to do all the high math that is involved. The other aspect is that it gives them the ability and freedom to choose what modules to use or to input their own ideas. And the third thing is that it gives us the opportunity to actually have feedback from our actual target market, the students before and actually also the teachers as well.
To do this, we're going to need three things: access to engineers, collaboration with different teachers' unions, education associations, what have you, and funding. That's actually the reason we're here today is to get funding to develop those first two things, which is ongoing relationships with education programs, public schools, colleges, student design projects, pretty much anything that inspires that spark, gets that going, first robotics programs. And the second portion is to get engineers involved. And what we want to do ultimately is to develop a pilot program with this initial funding, this initial startup, and develop that into a product that we can then sell to classrooms, teachers, students, and branch out. Ideally, in 10 years from now, we'd be in a manufacturing company who's developing these kits as teachers, students, other open source areas, continuous improvement, you're continually developing new products and building what it is they want.